Good morning everybody, this is Tommy and today we're going to build the second part of our voltmeter. If you didn't watch the first part, please go back and watch it. So I will not spend any more time and we will see on my workbench. So here we are again, guys. Last time we built our voltmeter with our LCD, our Arduino One controller, and we set all the things we needed for read the voltage of a battery. But today we are going to do another thing. What we are going to do today is to upgrade our voltmeter using another breadboard, a power supply module, 3 resistor, 1 capacitor, and some wires. So we have to connect 2 female male wire. We plug in our female part on the 5-volt terminal and we lead it to the red row in our breadboard. Then we take another female and we plug in into the ground terminal. As you can see, we have a 5-volt terminal and ground terminal. So plug it in, we'll add it to the blue row of our breadboard. Now what we have to do is to take 3 10 kilo ohm resistors and plug them into our breadboard in series. In series means that we are all connected by the same line. For example, we start putting the first resistor into line 15 to line 20. Then we take the second resistor and from the line 20 we plug in it into line 25. Now we take the last resistor and from line 25 we plug it into line 30. Okay, so now we have 3 resistors in series. As you can see, we have the line 20 that share one leg of the first resistor and one leg of the second, and we have the same on line 25. So these 3 resistors are in series. Once we have set the 3 resistors in series, we have to do a sort of loop with the current we will have from this power supply model. So we take a black jumper wire and from the last row of the last resistor we plug it in the blue column of our breadboard. Then we take a red wire and from the first row of the third resistor we plug it in the power column of our breadboard. Now we take the A0 wire, the one we used last time, and we plug it in the same row of the red wire. And we do the same with the black wire at the same row of the new black wire. Okay, so now we have just to connect our Arduino Uno controller, and as you can see, the read of voltage is equal to 0 because this power supply module has not been connected to the power. But if we connect it, the voltage is 5. So now the voltage is 5.04 volt. But we can use even the second terminal, so the 3.3 volt, and if we connect the 2 female to these terminals, the voltage will be 3.3. Okay, so now we return to the 5-volt terminals. Okay, so now we want to know how much each resistor use of voltage. So the only thing we have to do is to take off the black wire coming from the first breadboard and plug it into the last row of our third resistor or the first row of our second resistor. So as I plug it in, the voltage is 1.7 more or less. This resistor use a voltage of 1.7 volt. We can do the same from the second resistor. So we plug it into the last row of the second resistor or the first row of the third resistor, and the red wire we plug it where the black wire was before. We can do the same for the second resistor by taking off the black wire coming from the third blackboard and plug it in into the last row of our second resistor or the first row of our third resistor, and then taking off the orange wire coming from Arduino One control and plug it in where the black wire were before. So now, as you can see, the voltage is the same of the third resistor. We can do this even for the third resistor, but the voltage will be the same. Now we have calculated the voltage of each resistor. As you have seen, they are all the same. But now what we want to do is to calculate the voltage of two resistors and then the voltage of the all three resistors. So we plug in the orange wire into the first row of the third resistor and then the black wire into the end of the second resistor. So for one resistor the voltage is 1.7. For two resistors the voltage, as you can see, is 3.4. And now we have to do for 3 resistors, so for 30 kilo ohm. So we plug in the black wire coming from the third blackboard at the end of the third resistor, and the voltage is 5.04 voltage. So the all voltage is going through the 3 resistors. What we want to do now is to build a RC circuit. So a circuit that have a resistor and a capacitor. We are using now a 100 microfarad capacitor. So now we have to take off 2 of the 3 resistors we had and taking off the 2 black wires we had before. So now we are going to set the longer leg of our capacitor at the end of our resistor and the shorter leg at the start of our resistor. Now we have to take our black jumper wire and from the end of the resistor we'll plug it in into the blue row. Then we take the black wire coming from the first breadboard and we plug it in at the same line of the end of the resistor. So now the capacitor is taking power, and we want to know how many seconds it takes to discharge. So now we are going to push that button so the power will not be put into the circuit, and we are going to look at the value displayed in LCD. So I push the button and the display will show this. As you have seen, the voltage value will not be anymore going from 5.04 to 0, but it will go through different steps. In order to look them better, we have to move to our computer, run the sketch for our voltmeter, and have a look of our serial monitor. So see you on my computer screen. So guys, here we are on my screen on my computer, and I already verified and run the code to my Arduino One controller. So now we are going to run it another time and open our serial monitor. Okay, so the value of the voltage is going to be displayed on our serial monitor, and as soon I push the button of the power of our supply power model, you will see the value start to decrease. So as you can see, we add 5.04, 5.04, then I switch off the power supply model. The voltage display was 1.02, 1.41, 1.11, and then 0. So it has not a completely switch off on off, but it has a decreasing status. So guys, this was how to upgrade our voltmeter in order to let him read a voltage from our power supply model. I hope you like this video, and see you soon.